Hey everybody, how you doing? It's Steve on the Guru Brew. I wanted to talk about my homemade CNC machine today and a problem that I've been having with it. It's been having false triggers with the micro switches that control the limits. And even though a limit switch may not be tripped, it thinks that it has and the machine stops. And if it's in the wrong spot, it can ruin the whole job. Now this problem can plague CNC machines and other types of automated equipment such as 3D printers as well. The culprit is electrical noise. Whenever you have motors next to computer systems, the motors through the coils produce electrical noise, and if it's not isolated, it can offer false triggers. A way to fix this is optically separate the computer from the switches, and it sounds a lot tougher to do than it really is, and I'll show you the wiring and how you can fix this if you have this problem. Now the way I've been running this machine since I built it is I'll either turn off the limit switch function, which isn't a good idea, or there's a setting in Mach 3 called Debounce. And the higher the number that you put in for your debounce, the more it discriminates against electrical noise that may cause a false trigger. But again, this is just a band-aid. The proper way to tackle this problem is to optically isolate the switches from the computer that go into the parallel port directly. I'll show you the symptoms of this machine, and hopefully we can fix this problem. So let's get started. Now the limit switches on this machine are nothing fancy. They're just a small micro switch that is normally open, and there's 6 of them. There's 2 on each travel. Now if you have a vacuum system running and also the router running, that also adds a lot to the electrical noise. We're in Mach 3 of this machine, and I wanted to show you the debounce setting. If you go to config, general config, you'll see over here the debounce is at 200, and generally this number would be 0. Now it doesn't hurt to have a little debounce, but 200 is pretty extreme, but that's what this machine takes to ignore the static noise. So that is the problem. I'll try to show you what it does if I move this number down. Let's take a look at the motion of the machine. First I'm going to run the machine. I'm just going to jog it around on the 200 setting. So you can see the motion is okay. It's not affected. Now let's go ahead and move that debounce to 0. Config, general config, and we'll move this to 0. And okay. Reset. Now let's run the machine with the debounce set to 0. Okay, it stopped. Let's take a look at our screen and see what it says. So you can see here on the status line it says limit switch triggered. So even though none of these limit switches have been triggered, it thinks that it has. So that is the problem. Electrical noise can also come from things like routers and spindles, vacuum systems, fans and other moving parts in computer equipment, vacuum pumps, oilers and compressors, even fluorescent lights, especially if they're on the same circuit. So when you have a problem, you first should look for other people that had the same problem. Why reinvent the wheel? And so I went on the internet and I found some schematics that someone had done this exact thing with their machine. And I looked them over and it made complete sense and it was affordable. These Chinese optocouplers, you can see the listing here, all the way from China for $1.51 each. And this is what you get. Yeah, they're pretty small. And those are dual channel, so we're able to do 2 of the 3 channels with one. But I bought some extra ones just for in case, you know. But I studied these examples that they drew out here, and I think it'll work for my application. I need to change just a couple little things for my circumstance, but I'm going to pretty much follow these schematics. And I drew out on this whiteboard how I am planning to do mine and the channels that I'll be using. But the first thing I want to do is take one of these boards and put it on a little breadboard and test it before I put it in my machine. Make sure it's doing what I think it's supposed to do. SparkFun also sells these, and if I would have known that, I would have gotten the SparkFun ones. But at the time I didn't. I was just following the recipe shown here, so I bought these, and they came from China, and I think they're knockoffs, but they all use that same chip. These are 2-channel optocouplers. And I'll get a tight up shot of these. Pretty small. Here's my finger. There, how's that? That took a bit to get in the camera. So it comes with these pins that you can install on each side of here to install on a circuit board, or you can just connect wires and they leave these off in case you don't want to use them. I'll be using those because I'm going to put them in this breadboard for testing. This center part, this chip, is the actual optocoupler, optic coupler, and it consists of a diode and a receiver. So light shines on the receiver to activate the transistor, which is basically what it is, and there's 2 of those inside here. So you can see the pins coming in and going out. There's a ground and 2 signal pins. There's an out and an inside. The in would be from the switches and the out would be to the computer. You can see there's 4 resistors here to limit the current on board. And these are those 2 transistors for each of the channels. Oh no, it shot across the room. I need those pins. I found it right away. Lucky. I wouldn't mind sticking this upside down. If I put this upside down, I can see the labels on the bottom. I think that's better for me, isn't it? As long as I clear. Yeah, I can have the components upside down. And I can see the pinouts. I think that's much better. I haven't soldered this small in a while.
lot of practice. It's something that you have to stay with to be good at, especially on this micro scale. I know they're smaller, but to me this is small. Alright. Now I'll get my trusty toothbrush and just give it a scrubbing. And check and make sure that all those joints look good. I know you're supposed to put these on the other way, but I like this way because I can see the back as I'm wearing, and it's not hurting anything. Okay, I'm going to get some wires and start hooking something up here and testing this. This will be our signal wire, just for testing. And this is our micro switch for testing. Jumps up to 5.7, 5.8, that's what's in these batteries. This is based on a normally closed switch, and mine's normally open at the moment, so I need to turn mine around so that they're the other way. And the idea behind running a closed circuit, if a wire breaks, you'll be informed. Or if the circuit breaks, you'll know there's something wrong before you run your machine and find out you don't have any brakes. Yeah, that confirms. I'm just running one channel out of the two, just for a test. At the moment I'm testing out 2. I can move this wire over to 1, and then this one instead of 2, make it 1. That should be my second channel. Let's see if that one responds the same way. .8 volts open circuit, and about 9 millivolts closed. So yeah, that's channel 1, and channel 2 is independent of that. So there's 2 on board, so I'm going to have to use 1.5 of these. But since I have an extra 4th channel, I could always hook it up to another pin. But currently that machine only uses 3. X, Y, and Z. The schematic didn't include this, but I thought a LED indicator would be nice, so I'm going to put it on the output with a resistor. I'm turning this on with the power of light. It's amazing. It's fantastic. Inside the opto-isolator board, there's this chip, and the way that it works is these 2 little things are LEDs. There's, channel 1 and channel 2, if you want to think of it that way. And then on this side are the receivers. So when this light turns on, it hits the receiver, and then it goes through the transistor and it turns on the power through air. And of course these are isolated with a barrier, I'm sure. But all inside that tiny little square that could probably fit on the head of this pin is inside here. So channel 1, channel 2, light turns on, the receiver sees it, turns on the transistor, and makes the relay process happen. Here, I even drew you a giant one. You like my art skills? So after thinking this over, prototyping this and testing it, I think this will work perfect. And I also think that these chips should go down closest I can get to the parallel port input, which is inside the controller. And then from there, the switches with their 5 volts on them will come down into the case before they meet this. In other words, the closer I have this to the parallel port output, the better on the computer. Shortest lines as possible. So what I'm thinking I should do is get the controller and crack it open and do the changes inside it, is what this is amounting to. So this is going to take a little longer than I thought, but to do it right, that's what needs to be done. And it wouldn't hurt to just make up a perf board with all this stuff on there. So I'm thinking, go ahead and disconnect that controller and start taking the cover off and doing the changes internally. However, I'm going to stop the video here because this is going longer than I thought it would. And I'm not ready to crack that open just yet and devote time to it. It's probably going to take an entire day to do this change. But I want to hear your thoughts too before I crack this open. How are you guys doing with static and fault signals? A lot of the commercial machines aren't going to have this problem because they've already isolated or found ways around it so that they don't have to keep fixing machines. But the home brewed machines like mine, especially if it's made out of wood or some other unconductive material, may suffer these problems. So I want to hear your thoughts and know how you fixed it, and if you have. This is certainly a solution and I know it will work, but like I said, I'd have to devote a whole day, and I want to get this video out and get some feedback going before I actually use those isolators. So with that, I'm going to sign off for now. Thank you very much for watching. I appreciate it. I came back after not making videos for a couple years, and I'm glad I did. It's sparked a new interest in different things, and I enjoy working with you. It feels like with the feedback, I'm kind of working with the audience, which is neat. So let me know what you think about this project. Give us a thumbs up, and please comment. Say, hey Steve, whatever in the comments. All that stuff helps YouTube to rank me higher. And the higher I go, the more I earn, the more I earn, the more I can do. And the happier I am to make videos. So, with that, thank you very much. We'll see you on the next one. Bye for now. This is a dead tick that bit me, and I caught him, and I put him in this bag in case I had a reaction. It was a baby. I don't know my ticks.